Hey everyone, welcome to our next unit. We are just finished vectors and we're going to tie some information to our vectors in our next unit called polars. And the tail end of polars we will actually go through and talk about parametrics as well. So let's get started. Okay, today's warm-up, I would like for you to take a moment with the right triangle ABC, solve for the length of AB and the measure of angle A. And I'll pause, give you a moment, and be right back. All right, welcome back. Let's go ahead and start solving. So for the length of AB, that is the hypotenuse of your right triangle. So what are you going to use to solve for the length? That is correct, Pythagorean theorem. Now, what did we just use this for in our last unit in vectors? Okay, so think about that for just a second. Hopefully you got the square root of 3 squared plus 6 squared. 9 and 36 is 45. And the square root of 45 simplifies to be 3 square root 5. That is how I prefer the answer. We will be converting to decimals with other things as we go through the unit, but for this kind of thing, you can do this. All right, so quickly, just think about AB. If this is a ray, that would be vector AB. Cool. So when we actually just solved for that length of that right triangle, the hypotenuse, we did the exact same thing that we did last unit and found the magnitude. That's exactly right. It's a vector from A to B. It's a vector. Cool. All right, so the next part is to determine the measure of angle A. So we have all three sides of the triangle, but I like to always use what I'm given. So the measure of angle A will be found by tangent inverse of the ratio of the opposite over the adjacent, 6/3. Type that into your calculator and you'll get 63.43 degrees. So that is how big that particular angle is. Look at the length of the sides and you'll notice that 6 is larger than 3, so angle A is more than likely going to be larger, will definitely be larger than angle B. We've got angle C as the longest. So, all right, in our last unit, when we did tangent inverse of any angle, that was almost always going to give us our reference angle. The only time it wasn't the reference angle is when it's in quadrant 1, because that was just our solution. So we're doing the same thing we did the last unit, we're just applying it to different types of information. So let's continue on. Here we go. All right, we are first going to start with converting between rectangular and polar coordinates. So the rectangular grid, that's the grid you've been working on for the longest time ever, your XY grid. And we write things as ordered pairs, unless we're talking about an actual vector in that particular grid, then it's a vector XY with those horizontal and vertical components. Polar coordinates, we are going to use a radius and an angle theta in order to get us the actual coordinate that we want so that we can plot it on the coordinate grid. And our coordinate grid is going to have a particular radius that we travel along angle measures. So we're going to be looking at a circular graph, circular grid as we go through. All right, so we're first going to find a fixed point on O, and that is going to be called the origin or the pole. And that's because we're at 0, 0. We're going to, from O, from that origin, we are going to construct an initial ray. Hold on, what do we call those things again? That's right, the initial ray is just like a vector. It is a vector, and we're going to call that vector the polar axis. So that is actually all those little lines that I drew outside. Not great, but kind of give you an idea. Each point that's assigned, point P, is going to be a polar coordinate. R is your radius, which is that distance from the origin to the end, P. And then theta is going to be that directed angle. So we're going back to direction angles, going counterclockwise, just like we've been doing since the beginning of the school year. No bearings right now, just regular angles coming off the x-axis. A couple of things that we've got to remember, super important. When the radius is negative, Technically, a radius is never negative. The negative tells you the direction. But when we get a negative value, what we need to do in order to graph that point is add pi to the given angle. And that's going to change our radius to be positive. Like, we'll rewrite it to be positive with the other side, the opposite side of that particular polar axis. When we graph in the next lesson, that'll make more sense. Today, our focus is converting between the two. So each pair of our polar coordinates give us a unique point, but they're not unique coordinates. And that's because we can continually add and subtract 2 pi to the original angle and get coterminal angles. Okay, so take r theta and add 2 pi or subtract 2 pi to the theta, you end up at the same spot you started at, but it has a different value because we've added the 2 pi on there. You could also, if you have that negative radius, you're going to add or subtract pi. More than likely you're going to add. All right, and then our last little thing as far as naming our polar coordinates is a polar equation is an equation which uses r and theta, your radius and your angle value. All right, here we go with converting. So we're given a point with polar coordinates r theta, and we want to connect it corresponding to those rectangular coordinates. So let's convert that and look at what you have. X equals r cosine of theta and y equals r sine of theta. Tie that back to the unit that we just did. What was that like finding for a vector? That's right. That's exactly right. It was the horizontal and the vertical components of your vector. We did the magnitude, or the r value in this case, multiplied by cosine of the angle, and then we did the magnitude multiplied by sine of the angle, given angle. Cool. All right, so that's how we get from polar into rectangular, back into the stuff that we've been doing forever. All right, go in the opposite direction. How are we going to solve for r and solve for theta given x, y coordinates? Think about what we did in the warm-up. Yep. Do exactly what we did in the warm-up. We used r. Remember, that was our magnitude. That's the Pythagorean theorem. R is going to be represented by the square root of x squared plus y squared, and our angle theta is going to be represented by tangent inverse of y over x. The things I need you to be mindful of, just like we did in the last unit, is be careful of the quadrant that your original coordinates are in to make sure that you get your r theta, really it's the theta part, get that angle correct, okay? So if you have a negative x, negative y, quadrant 3, as your original rectangular or Cartesian ordered pair, then I need you to make sure that that theta is an angle in quadrant 3. Do not forget, be super careful of that. Promise, we'll practice it. Here we go. Just as I said, I promised, here we go. All right, so the first chunk we're gonna do are converting from polar 6 comma theta into Cartesian x comma y. Okay, so all we gotta do is to determine our x value, it's gonna be r multiplied by cosine of theta. So radius is 6 multiplied by cosine of pi. All right, use that unit circle, guys. Yeah, you can put this in the calculator, but your unit circle, or if you have it memorized and remember, is so much faster. It's no work. Cosine, your x value at pi, is -1. Therefore, 6 times -1 equals -6. Cool. All right, now find your y value. Y is going to be your radius multiplied by sine of theta. Okay, so our radius is 6 multiplied by sine of pi. My y value at pi is 0. Anything times 0 is just 0. So our y value is 0. So our polar 6 pi turn into -6, 0 as rectangular or Cartesian points. So think about that as your unit circle. here is pi, and I go out 6 units. So if I was just thinking x, y, this would be -6. Yep, there we go, comma 0. We got it. All right, number 2, our theta is 1/2, comma 3 pi over 4. We want to convert into Cartesian rectangular points. Another term that we use for polar is trig. Sometimes you'll hear that as well because you can write them a little differently. All right, so x equals my radius 1/2 multiplied by cosine of theta 3 pi over 4. And cosine at 3 pi over 4 is negative, and it's a square root of 2 over 2. I remember all my pi over 4s, they're root 2 over 2 every single time. Multiply those together and you'll get negative square root of 2 over 4 for the x coordinate. What are you going to get for the y coordinate? What do you know about your pi over 4s? That's right, they're always the same number. Signs aren't the same, but they're all square root of 2 over 2 every single time. So sine of 3 pi over 4 is positive square root 2 over 2. When I multiply that by 1/2, I get positive root 2 over 4. So in this example, number 2, our Cartesian points that are corresponding to the given polars are negative root 2 over 4, comma positive root 2 over 4. Boom, there we go. We've got a couple more of these to practice. Let's see how we do. If you are using the calculator, just in case, make sure you're in radian modes. How do you know that you need to be in radians? Because you're given a radian. You're given theta. It also says the word polar, okay? But if your directions just say convert between, look to see if that second part of the ordered pair is an angle, whether it's in radians or degrees. Just check to see. That's how you know. All right, next couple overs. Here we go. Number 3 says our theta is -2 pi over 6. All right, so let's think about that for just a second. We did just hear that if we have a negative r, that we need to take theta and add pi to it if we are going to plot the point. Okay, so keep that in mind, just remind you little things when we get there. So if this were Cartesian or rectangular, that's a negative x and a positive y. Interesting. Let's see what we get. Let's just do it. X equals your r value multiplied by cosine of pi over 6. So -2 multiplied by cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2. And when we multiply those two values together, it simplifies to give you -√3. Find your y value. -2 multiplied by sine of pi over 6. And that works out to be -2 multiplied by 1/2, which is -1. Okay, so when we convert from a negative radius and a positive theta, that one gives us a -x, -y in this particular case. Our Cartesian points are -√3, -1. Okay, so think about pi over 6 and where it is on your unit circle over here in quadrant 1. If I add pi to that, so just as a visual, if I add pi to that guy, I'm going to get 7 pi over 6, which is directly opposite in quadrant 3. There you go. That's a little info for the next lesson we're going to do tomorrow. So, alrighty. Our next one, the last one of this set, is our theta is 10 comma pi over 3. My radius is 10, it's positive, and my angle pi over 3 is also positive. So cool, shouldn't have any issues with this one. X equals radius multiplied by cosine of pi over 3. Cosine of pi over 3 is 1/2. So 10 multiplied by 1/2 equals 5 for your x coordinate. And y is 10 multiplied by sine of pi over 3. And sine of pi over 3 is the square root of 3 over 2. 10 divided by the 2 will give me 5, so that will simplify to give me 5 square root 3. So this Cartesian point is 5 comma 5 square root 3. That is in quadrant 1. Fabulous. Our initial ordered pair as a polar coordinate was in quadrant 1 as well. All right, now we're going to do it the other way. Now we're going to convert from rectangular coordinates to polar coordinates. So we have to remember, how do I find the R value and theta? Practiced it in the warm-up. Don't forget, your radius is the square root of 0 squared plus -3 squared. Shortcut, you can drop the negatives when you're doing stuff with Pythagorean theorem or squaring a term, because it's always going to be positive. So that radius simplifies to give us a square root of 9, which is 3. Fabulous. All right, when we use our calculator to find theta, we have tangent inverse of -3 over 0, and my red flags totally just came alive. 100%, because you cannot divide by 0. That is undefined. Okay, so what angle do we use? Where are the two places that tangent is undefined? Do you remember? At pi over 2, tangent is 1 over 0, and at 3 pi over 2, tangent is -1 over 0. Both of those are undefined. Okay, so how does that help us? I know that's either 90 degrees or 270. How do we know based upon what we were given in order to solve that? We could have taken a break at the beginning and we could have just looked at this ordered pair, 0, -3, and just plotted it. Where's 0, -3? Okay, well, here, x, y, 1, 2, -3. There we go. There's 0, -3. That's right, down at the very bottom of our graph, which is 270 degrees. So sometimes using the calculator is not going to help you. You got to remember stuff that you know already. So our theta turns out to be 270 degrees, or 3 pi over 2, strictly based upon what we were given and that coordinate is at the end of the y-axis. So r comma theta for example 5 is 3 comma 3 pi over 2. Good job. All right, number 6, xy is 5, 5. Okay, visually, where is the point, the ordered pair 5, 5? Yep, exactly, it's in quadrant 1. So I know that my angle should be somewhere between 0 degrees and 90 degrees. So somewhere in between those two. I shouldn't have written that less than symbol in there. Let's just write 0, 2. There we go. And go ahead and take a moment, work ahead of me, and get the R value. And then you can also work ahead of me and get the angle measure. You know it's got to be between 0 and 90. R is the square root of 5 squared plus 5 squared. 25 and 25 is the square root of 50. 25 times 2, so that is 5 square root 2 for your R value. For theta, again, think about things that you know. Yeah, of course we're going to pop it in the calculator and just make sure that we're right, but 5 divided by 5 is 1. Tangent inverse of 1, where does tangent equal 1? So at what coordinates, what radians, I really should say, what radians does tangent have the exact same, your x and y are the same, so that when I divide them I get 1. That's always at your pi over 4s. When you type tangent inverse of 1 into your calculator, it will give you 45 degrees. You need to write your theta as pi over 4, okay? Another quick connection, like let's go back and do some geometry. If I were to sketch a right triangle and the bottom leg is 5 and the leg on the side is also 5, that is a 45, 45, 90 triangle. You didn't even have to do tangent inverse to get that one. Not at all. Okay, but we did just in case. So our theta equals 5 square root 2 comma pi over 4. It's always good to try to bring yourself back into things that you already know. All right, I'm being a little wordy on this one. We're at 20 minutes and we got 2 more problems to go. When you're using your calculator to go into polar coordinates, make sure it's in degrees, and then you can convert it to radians after that. So here we are, last 2 examples. XY is the square root of 3 comma 1/3. So my R value is the square root of 3 squared, which is just 3, plus 1/3 squared, which is 1/9. Y'all, let your calculator do that work for you. I mean, not that you can't do it, but you know, just go ahead and let your calculator do it for you. So we are going to get our value to be, as a decimal, about 1.8. So we're going to say the radius is approximately 1.83. Okay, so let's do our work for theta. Tangent inverse, I'm thinking this one may not be on the unit circle. 1/3 divided by √3, pop that into your calculator. So tangent inverse of 1/3, and then divide that by 3, and pop that in, see what you get. All right, for my calculator work, this one gave me tangent to equal 10.89 degrees. All right, so this example is not on the unit circle. That is totally fine. I am so perfectly fine with you giving me a decimal value for a radius and a rounded degree answer as the theta. And when we plot that, we're going to plot pretty close to 2 for the R and really close to 11 degrees, so like barely off the x-axis if we were to plot that point. All right, last one. I'm going to pause and let you guys try this one, see how you do, see if it's on unit circle, or see if we get some crazy stuff like we did for number 7. Okay, we are back, and let's see how you did. R is the square root of -1 squared plus the square root of 3 squared. Make sure that you're using your parentheses correctly. 1 and 3 gives me 4. Square root of 4 is 2. Okie dokie, got that. And our theta is tangent inverse of the square root of 3 over -1. Okay, so if you remember your values of tangent, tangent at all of your pi over 3's are going to give you the value square root 3. Okay, it always simplifies that when you do y over x. So I know this has to be a pi over 3 radian. When you type it into your calculator, you're going to get -60 degrees because your calculator is in degrees. Okay, so my R is 2. What's my theta if I'm going -60 degrees? Now I know a bunch of you are going to say, oh cool, it's 300. And I'm going to have to go, oh, I'm so sorry, it's not. Not 300 degrees. It is not 5 pi over 3. What you got to do, this is what I'm saying, you got to be careful. You got to go back to the very beginning. Where did we start? This ordered pair that we were given is -1 comma √3. What quadrant is that in? That's right. That is in quadrant 2. You have a negative x and a positive y. So in order to get the correct angle, remember, we're treating that theta as our reference angle. In quadrant 2, I've got to come backwards 60 degrees. So that means I went 120 in our regular direction, counterclockwise for our regular direction angles, and 120 converts to 2 pi over 3. So for number 8, hopefully you got 2 pi over 3. Fabulous. All right, so glad you guys made it through. Sorry this was a little bit longer. I yapped a little bit too much. Make sure you practice in worksheet A. There are a handful of problems that are not on unit circle that you'll have to use the calculator for when switching from polar to rectangular. And you'll always want to be in degree mode when you're working going from rectangular into polar. Okay, have a great one, and I will see you guys another day. Bye-bye.